In this section, we'll discuss different methods for solving quadratic equations. So first off, what is a quadratic equation? Great question. So up here in the box, it says definition of a quadratic equation. Quadratic equation in x can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers with a not equal to 0. If a was equal to 0, then that x squared term wouldn't exist. And basically, quadratic equations just look for this x squared, right? If it's a degree 2 polynomial equation, if the highest exponent you see is a 2, you're looking at a quadratic equation. All right, so there are different methods for solving quadratic equations. So we're going to see all these different methods. The first we're going to look at is factoring. So you guys are probably familiar with this. So for number 1, 2x squared plus x minus 3 equals 0. The instructions say to solve by factoring. You could use the AC method or the grouping method, whatever you call it, to try and factor this. Or you could just use trial and error, which I'm going to attempt. So I have a trinomial. I'm going to split this into two factors multiplied together to create that 2x squared. I know the beginning of my factors will be 2x and x. Those multiply to create 2x squared. And then for this c term, this would be my a, this is my c, which would be -3, and then b would be a +1, by the way. So for c, to multiply to -3, I'm going to have a 1 and a 3. One will be positive and one will be negative. And I just want to arrange those so that when I FOIL this out, the middle term will add up to +1. So let's see, if I have maybe a 3 here and a 1 here, the 2x and the 1 will be multiplied together to give me 2x, and then the 3 times x will be multiplied together to give me a 3x. If I want those to add up to something positive, a +1, then I want the 3x to be positive, and I want that 2x to be negative, which is controlled by that -1. And just a quick check before I move forward, a lot of times with these factoring examples, we've been factoring for 1,000 years, so we just kind of get sloppy. So I always do a quick FOIL check before I move forward. So foiling this out gives me 2x squared, then minus 2x plus 3x minus 3 on the left-hand side, and those two middle terms do add up to that +1x or plus x. So I factored correctly. Okay, cool. So I've got 2x plus 3 times x minus 1 equals 0. And now I know that for if these two factors are multiplied to equal 0, that means either my first factor, 2x plus 3, has to equal 0, or my second factor, x minus 1, has to equal 0 in order for those two factors to multiply together to give me 0. So I'm going to solve each of these equations separately. And this gives me my first solution, x equals -3/2. Or my second solution, x equals 1. So -3/2 or 1 would be solutions to this equation. All right, looking at number 2, solve by factoring. Change colors here. All right, so I've just got a binomial. I see that x squared, right? So 5 is my a coefficient. The -25 would be b. And then I don't have a constant term, so in this case, c equals 0. There is no constant term, just to point that out. So I can factor this, just factoring out the GCF, greatest common factor. I'll factor out a 5x, which leaves behind x minus 5. So 5x times x minus 5 equals 0. So I know that I can set the x minus 5 equal to 0, solve and get x equals 5. So this is one potential solution. And also, do not forget about your 5x. That's a factor as well. So we can set 5x equal to 0, divide both sides by 5, and get a second solution, which is x equals 0. So 0 or 5 are solutions to this quadratic equation. And I also just want to do a quick side example before we move forward, kind of looking similar to this. So if we factored, I'm just going to write a couple of versions of this. maybe x plus 2 equals 0. All right, so solutions to these 4 examples. So suppose that we had these equations, we factored them, and we're trying to solve them. So for my top equation, x minus 5, set that equal to 0 to get my solution. X equals 5. 5 is a factor out here, but we can't set 5 equal to 0, right? Because those are both just constants, and we know that 5 is not equal to 0 because it's a 5. Where if we look at the second example, similar to what we saw in number 2, now we have 5x squared times x minus 5 equals 0. So x equals 5 is a solution, but x equals 0 is also a solution. In this case, we can set 5x squared equal to 0, divide both sides by 5, then we have x squared equals 0, which means x has to equal 0 itself. Okay, so when the GCF has a variable component, that's when we can go forward and solve for an additional solution. In the third example, we would get 2 solutions. X equals -2 from the x plus 2 factor, and x equals 7 from that x minus 7 factor. 5 is a factor, but again, if we try to set 5 equal to 0, we know that 5 can't equal 0, so we're stuck. There's no variable component. But in that last example, we would get x equals -2, x equals +7, and then we can also set 5x equal to 0 to solve and get a third solution. So x equals -2, 7, or 0.